Thank you very much. My name is Stef from Grieken. I work as a technical program manager at Google's social impact team. So we focus a lot on open data and trying to reach out to developer communities and see how they're using data for social good. Before joining Google, I was a developer that founded the Open State Foundation in the Netherlands, which is the largest group of open data reusers there. And before going into my actual talk, I'm going to share the experience of what it's like to be a developer and working with standards and data in general. This was my team, quote unquote, 2,500 people that will donate an hour or two a month to build something civically relevant. We coordinate online. We had a core team of 4 that was actually working, but still limited time. And we wanted to build an application that was showing election results for the Dutch elections live on election night. So where do you start? You type in election results in Google. What you'll find is actually this is all the Belgian government that is providing election results. So not very helpful yet. So you go on GitHub and check out whether there's somebody else who already started working on a project around election data and how to share that. No results. Maybe somebody ran into the same issue of not finding that data. So you go to Stack Overflow where nerds gather and share how they fix stuff. No results either. And then you dig a little bit deeper and you run into Wikipedia and you find this specification. 64 pages to understand what election data is about. I'm not going to read that. That's way too much. So I look at the actual spec and download an XML file that contains it. The data that I'm interested in is actually the name of the guy and maybe the party that he belongs to. But the format is really very heavy, and I need to parse that into an app. Probably a mobile app, because we all know that mobile is really exploding right now. And to get that 2 kilobyte XML on over 300 or 3,000 candidates to a mobile phone application will maybe work in the Netherlands, but it's definitely not going to work in India or in any other company. So the spec is way too heavy, but I might give it a go. So I find out that the Dutch Electoral Council actually should provide this data, but it's not really their, well, they use the spec, so that's good. And I learned this through a friend. But they adapted the spec, so they changed it to a way that accommodates something else and made it even more complex. And it's not on their site, so we don't use it. Now I work at Google because I thought as a developer you can have a lot of impact in trying to open up this stuff by being very practical. And I'd like to talk a little bit about my experience thus far and what I've learned in working in this space for a while. So what you see here is search interest. And a while ago we at Google found out that people around elections are searching for a lot of this data. So they want to know who are the candidates running in my district. They want to know what the election results were. So just before the election, they're interested in where can I register? Then on election day, where can I vote? So we created a couple of tools around this. For example, this is the French presidential election result where on the night of the elections in search, if people were searching for this, they would find this data. And just recently we've launched this map also in search that provides basically all of the candidate profiles, things like how they voted, who they are, where they're running for all of the districts in the elections. Just getting this data was a big challenge. And I'd like to start with identifying some of the key issues that I've run into personally through the example I just shared, but also if you just look at what's happening online with open data portals and the way that this stuff is being provided. So first of all, between me as a technical person and governments, we have a difference in definition. This is, I've looked at, I gathered the metadata of 18,000 open data portals worldwide. Everything basically that's been published in CGAN, and looked at all of the metadata provided there and run some statistics over it. So first of all, 1/3 of everything that you guys call, or governments call data, is actually documents. So it's Word files, PDF files, stuff that's not structured in any way that makes sense to a developer. Or would just take a lot of time for like 3 guys in a startup to get into a format that would actually be workable. Then a big chunk is spreadsheets. A lot of it is archives. Geo, yeah, it's there, so that's good. Some images, and just a very small amount of web services. Actually, the US does a much better job at providing web services to people than we do here in Europe right now. Then the second question I would have if I actually find this data is, can I use this data? So I want this election data to be on a map. Can I actually use it? So for all the data published, over 15,000 data sets are not with a license. So people just, they assume if I put it online and I call it open data, that it's actually open, but that's not how the law works in Europe. You have to make it very specific. And my recommendation would be make it public domain, because then your reuse will increase tremendously. So CC0 or something that's similar to that. Then it hardly ever gets updated. So I'm sorry for the coloring, this is wrong, but this is, I think, 2 or 3 months after the first scrape. We looked again at all of the metadata. Actually, this guy did, Thomas Levine. And what you see here is that only a fraction, so all the red stuff of the data that's been published out there is updated into a way, well, so basically that provides a business case for people to start reusing the information in the right kind of way. And not even to start about formats, whether we have coverage. So for example, for election stuff, you probably need to go to every individual municipality to get this data. And we as Google can do that, but my local group is totally unable to fix that. So you have to get into, in the Netherlands we have around 300 municipalities, go to 300 municipal websites, see if they have a data portal, see if they have the data, and if they have the data, it's probably in a different format, maybe it doesn't have the depth or coverage, so it doesn't provide an incentive for me to actually start reusing this information. So how can we transform this? This is actually how Dale County in Alabama publishes open data on where their ballot locations are. And you note the subtle 2006, 2012. So how do we get this into this in a way that makes sense to people? And I'm going to try to share some of the things I've learned in my previous job, but also recently at Google. And I'm going to do that by showing you 3 different projects. So first is the voter information project. We try, with all of the standardization, quote unquote, stuff that we try to do at Google, is to start with an actual end user's problem. And the problem here is usually a simple question. It's, where's my polling place? So where should I go to do a vote? And actually this information wasn't really available and not really structured, though it's a very significant part of our democracy, being able to understand where you can vote, who your candidates are, that kind of data. So this is about polling place locations, the actual content of the ballots, so people that are running, and voter registration, so how do I register? And specifically in the US, that can be different, like on the county level, it can be different in certain states, so there's not like one golden rule for registering to vote. And we all know what's happening with turnout around the world, so we kind of want people to do vote. Just providing this very basic data set by working with civil society organizations, we gathered all of this data, got it into a very simple, basic format, and got it out to people. So this is all of the stuff that was in there. Over 100 apps built, almost 40,000 candidates that we gathered, more than 600 sites embedded it, and we're talking about 2 weeks of querying. So 23 million queries on this data. So people are interested in data around elections. Very basic format. This tool, actually we use it as Google too. to give people data on where they can vote in search. So on election day, you would get this box. If you type, where can I vote? You would actually get a map of those specific locations. And others have used it. CNN has used it to create their elections map. Foursquare used it to tell people where voting stations were. The ballot.org used it to map out candidates for local precincts. AT&T used it, and civil rights lawyers used it. Awesome. Main takeaways from this project is you need to start gathering it at scale for people to actually reuse it. And it has to be simple, really simple for a developer to consume it and use it. 60 pages of spec is too much. They're not going to read it. They're not going to reuse it. If you're focusing on app developers, you're focusing on 3 guys at tops with a very limited amount of time. And they can't sit down, go into meetings, discuss for 3 weeks what spec they're going to adopt, and then run it, because they're bankrupt by the time they get into actual development. So they want to go fast. The other one is also very, I think, basic geographical data. It's about where do municipalities or other political divisions actually stop and go over into another one. For anything social impact, this is very important, because you have to understand if this person lives here, then this is his mayor, this is his council, his social services bureau, his whatever government service is provided to a specific area. It's very fundamental that people understand that if they want to build apps on top of that. For example, what are the shapes of all of the states in the US? Or maybe even granular, what are all of the wards and boroughs of the city of New York if there is a mayoral race? So basically we're talking about how do we break up countries into different administrative and political geographies. And especially around democratic projects, this is very, very important to have. So we came up with a standard that is actually just this. This is what it is. And you have a very big CSV file that maps it to any shape, or maybe even one of your standards, where people can start reusing it. But very basic tabular stuff. We put this online for the US only as an example, because we wanted to share this data. Right now, I think we're in 23 countries. Local civic developers have started to create this for their own countries. So Sweden was just added, Germany is added, I did the Netherlands. And so they're basically, if you give people very simple basic tools, they'll start creating this stuff for you. And that's really convenient. So to kind of support this movement a bit more, we created a Google Civic Information API, which is actually a web service for this data. Instead of providing the raw stuff, we provide it as a web service. And this API basically contains 3 things. It's currently US only, but I still think it's pretty cool. It contains all of the informational elections programs that we have run, and where we were able to share that data if we didn't license it. It contains for the US all the representatives and how they are mapped to basically any political geography. And it contains outlines of all the administrative areas that are available in the US, or at least mappings to those things. So official sources usually provide the mapping, and we map to those official sources. Over 25 million queries. We've launched this in December already. For example, this website, change.org, you might have noticed, know this. This is the biggest petition website in the world. And they had a very fundamental problem. Who do you send a petition to? Right? So your user is not going to know that. If they have a question about something, in their local neighborhood, they probably should address the council. If they have another issue, they might have to address the president. They didn't know. So they're using this API to understand how they should address a petition. The last example is GTFS. I think it's actually the first standard that kind of came out of a Google project. GTFS stands for Google Transport something standard. What's it again? Sorry, I always forget the names. There's so many acronyms in this space. What it does is it supports we really need to get to our users, which is public transport data. That's data usually created by local transport agencies, and they want to share it with us and with others. But we run into the same issues that everybody else runs into. How are you going to get it from A to B and make it nice to users? It actually started with the IT department of the city of Portland. And they started with the actual user question. So they said, how do we get transit directions included in all of the mapping sites in the world for our city, for the city of Portland? So they reached out to us and said, hey, we basically have two types of data. We have static transport data, which is the tables, when the lines are running, all that kind of stuff. And then there's the real-time transport data. That's delays, actual locations of buses, that kind of stuff. And we created a standard. Actually created a set of simple tables that you can run from a text file. So the agency is basically all the metadata on who the agency is actually is, so we know what we need to show on the map as the source. Locations of stops, routes, and how they hit the stops, trips, which is actually the schedules, stop times, depends. So if you have a different type of bus, sometimes they just stop at certain places, and calendars, which is a definition of time. And this standard is maintained by a mailing list. That's it. They don't convene. If you want to change something, you just send an email and give a use case. And if you actually implement it and people like it, they'll adopt it in the standard. So a couple of things that we've learned that I would like to share. First of all, play to your strengths. As a government, you're really good at providing basic services in a very reliable kind of way. And governments are really good at doing that. It's riskier to do rapidly iterating, innovative things that in 90% of the cases are going to fail because ministers and public officials don't like it when things fail. So play to your strengths and make sure that the service is reliable, but then count on others to do innovative stuff with it. The second thing I would like to share with you guys is it's not about the actual apps. It's about the ecosystem of people that you create around something. So it's actually getting these developers that you're building for in one room, and the actual coders, not just the people that manage them, but the people that actually have to work with it, talk to them, understand what the problems are that they run into, understand their use case. GTFS is used by us, but also by 500 others right now, and over 180 transport agencies. We don't copyright it, it's not ours, you can use it. It's a very convenient way, and if you can get 500 people to sign up for a standard, it's pretty good. It's actually pretty good. The other thing is you have to actually focus on the end user. So a lot of the data discussions also that I've seen today are about how are we getting something abstract to something other abstract. So a organization has to work with another abstract idea of an organization. And it's not really focusing on a specific problem that somebody has. So, for example, this is what I would really like to work on is air healthy around me. That's a very specific case, and it requires a specific set of information that you would need, which is spatial information, obviously. Then, if you have a standard, and if you want to work with these end users, you have to build for developers. So one of the reasons I think Google has been a very successful company is that we try to focus on what the developer need is actually. And we create APIs on top of most of our products. So Android, we have to work with thousands and thousands of developers to actually be able to utilize this phone. Google Wallet, YouTube, Plus, Maps, Class, Chrome, everything. In everything, we try to focus on what the developer wants, create a very good developer page. I would really recommend you go here, but also go to the Facebook's developer page, go to Twitter's developer page, and look what you find there. That's what most developers would like to see if they start a new project and want to start reusing some of your stuff. Start simple. So focus very specifically on what the use case is. Use very simple web native formats. So I don't know what the standard was, but I saw one coming by. So 3 of them were mentioned today, I actually started opening them on my computer, the actual files. I can't read the files, which means I need proprietary software that I need to get somewhere. I can get it in simple tabular form. This is not how the internet works. The internet is about simple tabular, basic stuff that you can represent as hypertext, so as in a text-based format somewhere eventually. Think about that. Also think distributed. So how can somebody replicate this work? GTFS wasn't designed as something that Google wants to ingest only. It was designed as an ecosystem thing. Everybody can replicate what we're doing because it's open, it's ready for everybody. And we thought about this in designing it. It has to be distributed. Otherwise, people are not gonna use it, basically. The fourth is make it tool or platform agnostic. So you shouldn't have to buy a license or very expensive software to use it. Otherwise, as a group of free people without an investor, you're just not going to use it. And provide just a basic set of tools. Actually, if you're going to provide any tools, provide one thing: a validator. So anybody should be able to throw data at you, and then your thing should say no. For example, in GTFS, a lot of times people will have entries that say the bus will go and leave at 3 and arrive at 5 before 3. That's not possible. So that means something's not going right in the transition of the information. So write a simple validator that any developer or person within an agency that wants to work with your standard can use and throw his current feed at, and then, oh, it still doesn't work, need to go back and fix it. Very basic set of tools. And try to get a quick win. Actually, our transport stuff was really horrible when we first launched it. It was just like balloons on a map that said, hey, there's a bus coming. And not very useful yet. But if you can show people the business case, like show them actual concrete implementations, people start to get it and start to get why the standard is actually important to them. And then lastly, try to keep this as light as possible as well. So propose a feature, gets a little bit of feedback on it, test it, so actually implement it, make it work, and if people like what's the new stuff that it's doing, you have a new spec. Again, GTFS just does this through a mailing list, and all the other projects I showed you were also on a mailing list with one moderator, and that's how they set the standard. That was basically my key takeaways for today. I hope that I was able to give you a perspective of a developer that actually has to work with this data, and I hope it inspires you to create really awesome standards in the future. So, thank you.
Does anyone have any questions for Stef? There's one question here.
Yeah, sure.
Yeah. First of all, I want to compliment you. We really need the kind of talk you're talking. I
Thank
believe
you.
that. And an eye-opener also, this, make it simple. I mean, we say we have open data and then we throw like 500 pages of specifications and not readable XML. So thank you a lot. I took a lot of notes and I will bring them home.
Awesome. Thank you. Any other questions? Yes, sir.
What do you think about, or how do you approach making it easier for governments to add data to your APIs? I mean, is it a matter of passively crawling whatever they open up, or do you actively engage and make it easier for them?
Depends. So the next step, if you actually have the tabular stuff right, you can start making it API-able and shareable. I think within government agencies, other government agencies are just users. So they will have developers that want to reuse stuff. And they probably hate it if they need to spend 3 weeks of like researching a spec. If you can give them like a nice API, that's great. But just start with tabular. It's like, I mean, they can probably create a prototype off of tabular. If they understand what your data is about, that works. Yeah. Anybody else? Yes, sir.
How many people work in your department?
Within Google Social Impact? 20. Yeah. Actually, I mean, I haven't told you, but in the Netherlands, the guys that run the specification for open data around Geo Data, about transport data, that was a group of 7 guys that spent half a day a week. That took them 3 months to go to, I think it's 23 agencies in the Netherlands, something like that, like the railways and all of the buses and these kind of guys. Actually, the technical implementation took them 3 months. Getting governments to sign up and agencies to sign up with this took them about 4 years. And they now have like a really awesome GTFS service for all modes of transportation, real time, ready. And it's community run, which is really cool. You can get like people to build your public infrastructure for you. But I don't think you necessarily need to have 300 people to build something good. You do need to focus on what the problem is that you're actually solving, instead of trying to design for any possible use case, because that's going to be very hard. And yes, then you can spend like hundreds of man hours on a lot of stuff. Excuse me? Yes,
What
sir.
if the developer, or Delta or OGC, what if your developer suddenly get distracted by some other cooler thing during the development phase? Is it like, half a day a week, 3 months, so on a voluntary basis?
Yeah, well, I mean, the nice part of paying people is that you can actually prioritize their work, obviously. But in designing a spec, I would aim for getting the volunteers. So if you can design something that is more cool than whatever else they were working on, you have a really awesome spec.
What I was saying is, you have to develop, transportation. Suddenly tomorrow, something else that's much more fun to work in a totally different domain. Then what?
With in the specific transport case, the source is open, and so I haven't run into a situation where something that was built right and where there was a lot of usage that people just suddenly left. There are like other people that will pick it up, or like corporations that start to think, hey, this is actually interesting because I could make money off of this. Or a government agency could come in and say, wow, you guys built like the public transport API for this country, so maybe we'll start giving you money. But these guys generally, they're not even like interested in subsidies and stuff. They just, they don't want that stuff. Cool. I think, I've already taken too much time, so thank you.
I'm Phil Archer from the World Wide Web Consortium. I'm not going to take up time explaining what W3C is. I hope you either know or can find out with the OGC of the web. All right. We ran a workshop a little while ago with Ed from Google and with OGC and with the UK government and with Ordnance Survey. And we had some presentations, and we had some questions, and we had some panels, and we had some discussions, and some people checked their email. So thanks to everybody who helped make that happen. It was done, from my point of view, on behalf of the Smart Open Data Project, which has a workshop tomorrow afternoon, following the one which Tina was talking about earlier on, which is what I want to really plug in the next few minutes. The point about the workshop and the work we're doing was summarized by, there are all sorts of things that we discussed, and I won't go into detail today, but if you want to sort of summarize the discussion in one presentation, it was this one, where Frans Nibber from Geo Data, another Dutch organization, was talking about these two characters, Miss Globe and Mr. Cube. So Miss Globe is the OGC world, the geospatial stuff, and I'm from the linked data, RDF semantic web world, and Frans, I emphasize, has given us permission to use these characters. And they're very useful to sort of put these things together. I haven't got time to go through what we talked about in any detail, but I will talk about this book which I read some years ago, and thinking about coming to this event today, I was reminded of this. This is a spider. This is an arthropod. It has extremely good eyes that are different from yours and mine. I can't use this thing, it's attached, and I'm trying to do it quickly so I don't spend time fiddling with the technology. Spiders have really good eyes, but they're not like yours and mine. And they've evolved for billions of years. The first spiders have been, certainly 2 billion years since spiders are around. They've been around a long time, and they're very good. But the point about evolution is that every time something changes, for it to survive, it has to be better than what happened before. Now, you might think that you could genetically engineer a spider to have stereoscopic full-color vision, and you probably could. But that requires major surgery to change what a spider has and then somehow insert primate eyes, and that's not going to work. For it to happen naturally, every step between these very good eyes that they already have and have spent a lot of time and effort evolving over the billions of years, to go from that to having primate full color stereoscopic vision. Every step you take between those two is worse. It gets worse, and that therefore isn't going to happen in reality. So any kind of evolution of working with the geospatial world and the web world, putting the two together, requires that every step is progressive and every step is better. And that is the challenge that we face. The problem is there are loads of standards. There are also projects that have documented all their stuff and put it on a website and called it a standard. There are all sorts of ways of doing stuff. For example, there are 4 different ways of describing geospatial places just in RDF today. GeoSparkle is an OGC standard. W3C Basic Geo is something Dan Brickley knocked up one afternoon, and people have been using it ever since. Neo Geo is another competing one because some people don't like GeoSparkle, and the as a collocation vocabulary is one that Andrea talked about earlier on. They all have their own particular uses and niches, and we need to try and work out what to use. So we asked people at the end of the workshop, what do they want to happen more than anything else? And we got a bunch of replies, all of which boiled down to, can we please agree on how to do stuff? And there was no call anywhere for any new standards. Thank you, we have enough. Although some of them may need adapting a little bit so that they work with other things as well. Let me very briefly talk about the context of this from a W3C perspective. This is one of the things we're doing, of course, like every other standards body, like every other organization, we have lots of other things going on. So this is other stuff that's going on, and this is why we don't have to do it in the other work we're going to be talking about shortly. Stef was just talking about tabular data. We have a whole working group on tabular data, providing metadata for that will enable you to provide the data types and the column headings and the row headings and annotations for individual cells within tabular data. That's co-chaired by the technical manager of the Open Data Institute in London and Dan Brickley from Google. One that I didn't think would be quite so relevant today as it clearly is, going right back to what Adam was talking about at the start of the day, and other things that have come up. We have a working group called Data on the Web Best Practices. This is where we are doing a number of things around building the ecosystem for open data, extending DCAT to cover quality, granularity, making it easy for people to voluntarily tell you that they're using your data, and generally just making sure that people share their data and use data in a way that actually helps everybody and builds up that ecosystem. So that's a large group that I'm team contact for that one. So I'm very pleased that that is really making progress. Link Data Platform will be of less interest to you. Hydra Community Group is working on standardized API documentation. That means you can have one bit of code that with the right metadata could use multiple different APIs providing different bits of data. That's something I hope will be on the standards track next year sometime. Andrea mentioned the location and addresses and so on. And something else again that has come up since I arrived in Aalborg that again could be relevant is what we call RDF data shapes. It's, if you're familiar with XML and XML schema, where XML schema will tell you, okay, this element must have these children, and these children must have these kind of values, these sort of enumerated values, these predefined shapes of things. That's what we're doing for RDF. The DCAT application profile that Andrea talked about is a very important use case of that. So that's what we're doing elsewhere, very quickly, too quickly for you to take it all in, but there's a lot of stuff happening. And we're also leading a thematic network. This is a plug for another EU-funded project, so I can say I gave dissemination about it in the project review. Bunch of workshops coming up, one at the end of this month in Samos, which is about uses of data within government for greater efficiency. Other projects coming up you can see on screen, I don't need to read them out. We're working with OGC on that, and there are other standards bodies, lots of governments involved in that, so lots of things going on there as well. So those are the kind of things that W3C does in that sphere. But what you really want to know about is this, which is when Atina and Bart and their colleagues and I and my colleagues get together and we start thinking about things like this, which I'm not going to show you for very long because it's still not done, but we are clearly working actively on working together on a new working group, And we have this workshop tomorrow afternoon at 2 o'clock. I wish I knew where. And it'll be talking about this, which is the draft charter for a working group where we'll be doing stuff together. Because there are things where, I'm not going to say which one of us is a spider and which one of us has the primate eyes, but we're both highly evolved ecosystems. And we have to try and come together. So we will be working on that business of how to put stuff, how different people can work together so that both sides of the community can work together. Some things came out of that workshop that are really important. Time is a coordinate reference system itself. There's some earlier work that W3C did that needs finishing off. Sensor networks, how do we incorporate those? Coverage information, satellite information, and so on. So there's quite a lot for us to get our teeth into. It'll be an important group. And if you want to find out more, if you're a member of OGC or W3C, or ideally a member of both, and would like to become a member of both, then that workshop tomorrow afternoon will be going through this charter and trying to make something that we can really take to our memberships and see what we can do. I'm sorry that was 8 minutes, but that's all I've got. Thank you.
Good afternoon. I hope you all had a very nice lunch. It's now digesting, and then I can rumble a bit through your digesting process. This question, where is my school, has been occupying my life for the past 1.5 years. And actually our whole family has been working on gathering school data in Amsterdam recently. My name is Job Spierings. I work with Waag Society. That's an society for social innovation in Amsterdam, and we do a lot with creative technology. And we're gathering this school data because our eldest son has just turned 12 and he needs secondary education. And I will repeat this process of gathering data at least twice more, since we have 3 kids in total. And it's a very complicated issue. Of course, it has to do with the capabilities and interests of your own kids. It has to do with the rankings of the schools, how well they are doing. There are lists on that. But it also has to do with where this school exactly is. We live in Amsterdam, and Amsterdam is a relatively small city. About 1 million people live there. And it's designed for bikes, not unlike Aalborg, what I saw from this morning. But it makes a big difference where your school is. Even though it's not the biggest city in the world, if our son will have to bike 1 hour a day more with a certain school, that will cost him 5 hours a week, and that's a lot of hours during a time when you're six years in a school. Other factors are, is somebody from his school going to the same school so they can ride together? Is it safe on the bicycle path through there? Is there a safe route? If there's snow or rain with very bad weather, is it feasible to go there by public transport? Or do you have to make so many stopovers that this is not really a solution? Some of these schools are oversubscribed, so there will be a lottery. And so a lottery fate basically will decide to a certain extent which school you will have. In that case, it's very important to know if there are interesting schools in nearby cities, because in a city like Amsterdam, unless you live in a spot in the center, there's cities that are relevant in other communities that might be closer by or more relevant. Now, this is maybe a very, very personal process of finding a school, but I found that 2 things stand out. One, it's a very complicated process where you spend a lot of time on gathering just very basic factual data, such as where is a school, what are its scores, is it nearby a football field? And the other thing is that it seems to be almost impossible to have an overview. As I said, I've been studying this for 1.5 years. I still cannot say, for instance, how many schools there are in Amsterdam for the level that we are looking for. Maybe there's 8, maybe there's 10, I'm not completely sure. Well, this lack of oversight and being very busy with things that are maybe quite basic is not because the data isn't there, of course. We know, for instance, this is one of the schools in Amsterdam. There is a physical building, so I know it's there. That's knowledge I have. But there is also a Wikipedia entry, even in English, describing the school and its origins and the medieval Latin schools in Amsterdam. The Amsterdam schools have a foundation together, and they publish basic data on schools, such as how many students were in each annum, what their concept of education is, whether it's traditional or Genaplan or Dalton or whatever other specialities you have, whether they have special courses, such as philosophy or music or drawing, and how they schedule their classes. Of course, the school itself has a website where they go more into detail in how they approach each subject, so the languages or biology or physics. Maybe we can even find some information on the teachers on these subjects. OpenStreetMap knows very precisely where this school is, and it knows very precisely which other facilities are nearby. For instance, are there sports fields nearby, or music venues? Central government has a lot of data on schools. It also has a database on monuments. This is the National Monuments Database. And it makes a relation between this building and its architect, and buildings that are from the same style or from the same architect or are in other ways related to this historical building. As Stef was talking, referring to before lunch, we have quite a considerable OpenTripPlanner community in Holland. And one of the interfaces showing OpenTripPlanner is Go About. They have this is a new travel planner they released this year. And it gives you a multimodal overview of all travel options in the Netherlands. So I can compare here traveling by car from Central Station to the school, or by bike, or by public transport, and I can see differences in cost and CO2 imprint. And all data and the analytics of the data are open. Then the city, of course, has data on who's in charge there. And this is finally the list which ranks the Dutch schools in number of qualities and examination results. Well, these slides have been mostly in Dutch, but you get the idea. There's a lot of data, really a lot of data, but they're all in silos, and I all have to manually access them. Data are in different formats, conflicting formats often. Sometimes there's a suggestion that there is data, but they're not there. I cannot work with this data because I don't understand anything of this, unlike some developers. So what if this cornucopia of open data becomes linked and accessible? What could we do? Well, for me personally, the most important thing that we could do is spend less time as a family on gathering very basic facts about where a school is and whether it is relevant in my subset, and focus more on whether I like that school and that approach and whether it fits the needs of my kids. But as a community or as a citizen, for instance, you could access data on where will schools be needed in maybe 10 or 20 years. I think it's very obvious that if you build a new neighborhood, that 12 years from building that neighborhood, you will need secondary education, because most people will move there, they will get kids, and in 12 years they need various forms of secondary education. Such analysis is occasionally done by cities now, but by opening it up and linking it, it would be possible for any citizen to, for instance, make a connection between the needs for education and the amount of vacant office buildings, and to start their own school. The real need, of course, is with government itself. To give an example in another domain, traffic in Amsterdam is managed by the city. Of course, they have some data, they have real-time data on where traffic moves. But the highways in Amsterdam, which are literally in the middle of the city, are managed by the state. Railways are managed by the National Railway Company. Trams are managed by the tram company. All these management systems provide real-time information in conflicting formats. no one has the total overview, not for live management and tactical approaches to traffic, but also not for analytical purposes, which means that if analytical research into strategies has to be done, this is very expensive and almost always behind the fact, because you have to collect data and analyze it afterwards. So for me personally, for citizens in general, and for government, this would be brilliant if you could access data in that way. This is where the project City Service Development Kit comes in. It was a project started in 2012, and its main thing was to have standardized interfaces. So with the objective to give every city in Europe the opportunity to develop its own service development kit. And service development kit is of course referring to software development kit, which is the technology that is used by many software companies to create their own ecology. An ecology of reuse of their systems and data and creating applications and services on top of their systems. And the idea is, if we have a set of generic APIs that use existing backend systems and existing data streams in the city, and they're standardized on a European level, then developers can make applications that are working not only in their own city or on a one-on-one basis, but that they are working over the whole of Europe. So you build an application or an analytics tool or a dashboard, and it becomes accessible in all these other cities. Cities that participate in this project are Helsinki, Amsterdam, Manchester, Lisbon, Barcelona, Rome, Lamia in Greece, and Istanbul. And we have done a lot of events to engage developers, do hackathons, and pilot applications in our project. Okay, back to the example. How does that work? There is a school. We know that there is a building or a parking garage. That's a physical object in reality. That's listed in OpenStreetMap and other databases. And we have all these data sets that are about this school, or about this garage, or about this street, or about this administrative region. We have those facts. So what do we need? We need a skewer or a toothpick and stitch it through our data and attach it to our object. This is what we've done in building the City SDK Link Data API. It is a web service that offers exactly that. Access to all data in different layers for each object in the city. And what is the most interesting thing of it is that you can add, for instance, a data set on real-time traffic speeds on the roads, and then you can query the database for what are the speeds on a specific city or to a house on that street. But you can also add your own measurements. So it is an open API, and it allows you to read and write about your city. Each object in the API is given a URI, a unique resource identifier, which is like a, well, bad analogy, an IP address for every object in the city that you can add all these layers of data to. It returns various formats: JSON, RDF, Turtle for the linked and data semantic web people, GeoJSON and JSON linked data. Who of you is comfortable with coding and these things? I don't know, because this is... Okay, that's considerable, sort of half of it. The basic of it is that if you ask for, as a developer or as a company or as an application or as an analyst, you ask for the data on the API, you get it in the most easy format possible. The API also is designed to work closely together with OpenTripPlanner, for instance. People that have done a lot of work on making route planning using GTFS, but also route planning for bikes and cars using OpenStreetMap. It also is made for analysts. Analyst is a great tool that I will get to at the end of my talk. It works closely with Open311. Is Open311 familiar here? not so much. 311 is the phone number you apparently call in the United States when there is something wrong in your city. When the light is broken or there is a pothole, you contact your city by calling 311. It's not an emergency, but something has to be fixed. Open 311 is a protocol for software applications to report issues on your street and send it to your city. Any city that has implemented Open 311 makes it possible for any of those applications to work in the city. And it's thanks also to City SDK, it's getting a hold in Europe. And of course it supports OpenStreetMap. Time to show some examples to show where the project is. One of the more interesting new data sets that we have in our API is based on the Smart Citizen Kit. This is an Arduino board developed by a Fab Lab in Barcelona. It's a very small computer and it has 5 sensors on it. And it measures light and sound and CO2 and NO and a fifth one that I forget right now. And the city of Amsterdam has bought a number of these, 100 of these sets, and they're hanging at people's homes. So what we're now doing is collecting these data at 100 points in the city. People that are individually collecting data on environmental circumstances at their house. And that can then be compared to data compiled by the city itself. For those of you who are comfortable with code, this is a JSON return from the API. And since there are some of you, I will quickly walk through it because it shows, I don't know if you can read it actually, but it shows that on the upper record shows the measurements of the Smart Citizen Kit, and the other two are linked to that. So you can see that the measurements here done was in a monument in Holland, and here we see data from the Dutch cadastre, the address records, where you can also see other details of the building. One of the other applications that you may or may not have been seen was featured in the in Wired this autumn, and it's a visualization of the Dutch cadastre, where the old city of Haarlem has been shaded by the year of construction. So we see here in the middle, this is the church in Haarlem, and you can click each building to query results that are compiled by the cadastre. And the visualization is made by MapTile or TileMap, and but the data is then queried from the API. This application was presented 3.5 weeks ago at the Amsterdam Smart City event, the city dashboard. And this is actually one of the first applications that gets to the area where we want to go. Have an integrated view of all those different real-time and static data sets on the city. What it shows is data that we have on public transport, but it also shows all the data that we have on traffic management. So you can see how many cars are, not how many, but how fast the cars are driving on main roads in Amsterdam. You can see how many parking garages, how many parking places are available in Amsterdam, and so you can see how the city is busy and calming down through the day, and then you can visually link that to the public transport data that are available. All these things I'm showing are open source and shared with the community for replication elsewhere. This is our most practical application from now. This is built by another company, but on top of this of our API. And what you see here is somebody who is going to Paradiso. Paradiso is a music venue in Amsterdam. You see it on the right upper hand corner. And he wants to visit it on the 11th of May for 4 hours at 8 in the evening. Now, he wants to go there by car, and so he obviously has several opportunities to park his car. He can park his car here at the traffic ring, and then continue his last part of travel by public transport. Or he can park his car just in front of the venue. Well, these have different consequences, which we see here on the right side. Some options cost maybe half hour of travel time by public transport. Other options are just will drop you off in front of the venue but will cost you 24 euros. And if you decide to use public transport, then it shows you the route and the timing as well. This is what I'm the most excited about. OpenTripPlanner Analyst is a tool built by a group of open source developers linked to the group that developed GTFS and OpenTripPlanner. And we're contributing to their research. And what it does is it makes an analysis of the travel options in a city between every point in a city to every other point in a city. That sounds complicated, at least to me, and it is quite complicated. What this visualization is, this is a beta, it's not live. This is the only application that is not live that I've shown you so far. And it shows from the blue marker, that's supposedly where my house is, and it shows me which schools can be reached within 30 minutes. And you see that it's quite unevenly distributed on the map. But this makes it really possible to have different scenarios on which schools are accessible from which neighborhood. But you could also do it, of course, with jobs. Which kind of jobs are accessible from which neighborhoods, or hospitals, or all these kinds of analysis. And it gets even more interesting if you add new public transport lines, because you can add a new public transport line and see real time how that changes the reachability of your city. Endpoints, we have now endpoints in 6 cities in Europe. They have all different data sets available. All of them have OpenStreetMap data linked to the public transport data and linked to administrative regions. Then we are quite good on having parking data real-time distributed. Some cities have a grid for electrical cars to charge and electrical bikes, weather data, and population statistics. What is next? Well, we would very much like to see other cities join us. City SDK has been a European project. There will now be a networked association that will continue to support the results of the European project after the project has ended at the end of this year. Secretary of this association is hosted in Helsinki at Forum Virium, which is a subsidiary of the Helsinki municipality. We will keep adding more data sets in Amsterdam and the Netherlands. Our partners will add more data sets and more services on the APIs in the other cities. And we'll also do more research and development, for instance, on the OpenTripPlanner Analyst. This is the URL if you would like to check it out or find links to any of the applications that were visible during this presentation. And I'm happy to see any one of you this afternoon or evening for further discussions. Thank you.
Does anyone have any questions for Jog before we proceed?
Oh,
Just one question.
Oh, yeah.
Thank you for the presentation. Just would like to ask you, you had to integrate a number of different data sources, right? So which was the most complicated issue?
One of the most complicated issue is the variance of complexity. One of the most complex data sets to add has been a DataX2 data set, which is, I don't know if any one of you is familiar with it, but it is apparently the European standard on disseminating real-time road information, the amount of cars, the speed of cars, the density of car traffic and accidents, etc. That has is a data set that is being collected nationally, and that the government is proud of, that it is according to Inspire regulations, but as it is using quite, let's say, old-fashioned
geolocation references, VILD references, it's quite difficult to map it to any more conventional geolocation system. So I think that one data set cost us about 300 to 400 hours to integrate into the API. Other interesting things that we are now working on is, this is of course a very simple model of linking data sets. It is capable of using semantic web, but it's not needed. So an obvious example is if you have a tram stop in OpenStreetMap and you have a tram stop in the GTFS file and maybe some other data set from a community center that's collecting data on whether tram stops are accessible for wheelchairs, you have 3 tram stops. And as long as they're on the exact same spot, you can easily link them. But if there are slight differences between data sets, you have to make negotiations. I think the main difference in approach here is that we try to take the easy and fast way to make the data accessible and usable and accept a certain amount of errors, where I suppose that from an Inspire kind of context you don't accept any errors because you're publicizing officially the data. So I think there's a difference in approach there, that the one is more agile and fast and the other one is more stable and correct.